The purpose of today's laboratory is to allow you to experience a little bit of what Mendeleev did when he created his first periodic table. And in order to do that, we're going to be reacting some solutions that have letters with other solutions that have numbers. Now, when Mendeleev created his periodic table, he first listed all of the known elements based on their atomic weights. That's kind of like our numbers. He then grouped them based on how they reacted with oxygen. We're instead going to group based on how they react with letter A, B, and C. But to make our lab a little bit easier, we're going to only focus on 9 numbered solutions. Those are our unknowns. And we're going to react each of the 9 with A, B, and C. So in order to do all of these reactions, we're going to use this well plate. And the well plate is set up so down the side, we've got letters A, B, C. We're just going to need the first 3 rows. And then across the top, we have numbers 1, 2, 3, 4, 5, 6, 7, 8, and we'll take the first 9 columns. What we're going to do is drop a single drop of the solutions in the appropriate cells or wells or these little spots. So for instance, we could start with our solution A, and we could drop solution A into the first 9 of these wells. We would then grab solution B for our second row, and finally solution C for our third row. Now, when we have just one solution in each of these 27 different spots, no reaction should occur. The reactions shouldn't start happening until we also add in the second solution, the numbered solution, into each of these holes. So in our first column, just for the first 3 rows, we would add a single drop of solution number 1 to A, B, and C. And then we would add a single drop of 2, 3, 4, the whole way up until we get solution 9 in these last 3. So each one of these cells then would have one solution that has a letter and one solution that has a number. And based on how the numbers react with A, B, and C, we can then group them into 3 groups that each have 3 different solutions within it. When you are actually dropping your solutions in, if you get an immediate result, even before you add the second drop in, that just tells you that the cell itself was dirty. You probably just want to pick a different row and try again. Nothing says you have to use row A, B, and C as long as you remember where solution A, B, and C are. Similarly, if you get a lot of weird results, you definitely want to just wash the entire well plate and start all over again. As you're going through our lab, when you're reacting the numbers with letter A, you're going to be looking for a precipitate. And a precipitate is nothing but a solid. It's kind of like a powder that forms from 2 different solutions. And because the solid forms from the solutions, it's going to fall to the bottom, kind of like rain falls from the sky, which is why it's called a precipitate. So the precipitate is a cloudiness that would form anytime one of these numbers might react with letter A. Same thing would happen with solution B. A precipitate would form. For A and B, sometimes it's kind of hard to see whether that cloudiness occurs. So one thing you might want to consider doing is actually sitting your well plate on some sort of paper that has writing on. You can probably see that you can still see the letters and the lines through most of these cells, but if a precipitate would to have formed, you would no longer be able to read the letters or see the lines. So again, we're reacting 1 through 9 with letter A, we're going to look for a precipitate. We're reacting 1 through 9 with letter B, again, we're going to look for a precipitate. And then finally, we're going to react letter C with those same 9 solutions, and for C, we're actually looking for a color change. And it's not just any color, it's going to be a bright magenta, really, really bright pink color if that reaction occurs. From the 9 different numbered solutions, we want a total of 12 reactions, which means in your data table, you should record 12Y. Y for yes, the reaction occurred. All the rest of the cells should then just remain blank. Nothing happened, you don't write anything. If you do not see 12 reactions when you complete the lab, you probably want to call me over before you dump your well plate, just so we can see which one you're missing. Or if you have more than 12 reactions, same thing, call me over so that I can check your results. You'll also have the opportunity at the end of this video to see the actual results that you should have seen for the lab. So that before you do your post lab, if you want to just check your answers, you absolutely can do that. And that will also give our distance learners an opportunity to see the lab occur. As always, if you have any questions, just let me know.
He was born in Russia in 1834. Hard work as a youth opened up the college doors. He always tried to be the best that he could be and chose to make his mark in chemistry. And who told the elements where to go? Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev. He wondered if nature really had a master plan, if the elements had a pattern that one could understand. So he bought a bunch of cards, and on each one wrote the name of an element and its weight, and then he played the game. He put them all in order by their atomic weights. He used their chemical properties to differentiate. Groups began to form, and despite some question marks, he managed to produce a simple periodic chart. Who told the elements where to go? Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev. At first in 1869, the chart was not a hit, but that young Russian chemist was not the kind to quit. He revised atomic weights and staked his whole career, predicting that several new elements would appear. A few years passed, and sure enough they came. Gallium, scandium, germanium were their names. Chemists everywhere were impressed with what they saw. There really must be something to this periodic law. And who told the the elements where to go. Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev. So they call him the father of the periodic table, and his work gave rise to another kind of label. It's the name for element number 101. In honor of this man, they call it Mendelevium. And who told the elements where to go? Mendeleev, who put them in columns and in rows. Mendeleev, who was ready, who was able to make a periodic table. Who was that chemist? Mendeleev.